Okay, this is to get you going on PYS 4.6, number 8 through 10. And these proofs are actually far more challenging than you would think. And it's because the way the diagram is marked, we can't assume things that aren't marked there, okay? And one of the hardest things I think for doing proofs is like you could look at something and say, hey, I know that's a right angle, but you know what? It's not marked. So we actually have to prove that if the left-hand angle is a right angle, well, then the right-hand angle is a right angle. We have to make the statements that prove that. And then from that point forward, we don't have to worry about it. But right now, we are trying to prove that DE is congruent to CF. And what I notice with parallel lines and those right angles is, you know, hey, if I can get to where I know I get something along the lines of a rectangle, right, that I can recognize that that's that, well, then I could get that these two sides are equal to each other. Basically, what I notice is I need to be able to state that this other angle is a right angle, okay? And it's not as easy as you think, okay? So we are going to start with the two statements, DC parallel to EF. These are givens, right? They're given through the diagram. And like I said, I can't yet make the statement that this is a right angle. I know it is, obviously, but I have to show that. I have to prove how I know that. So what I can also say is that DE, right, is perpendicular to, let's just say, AB, and CF is perpendicular to AB, okay? I could say that that is given. That's what it's told me, that these are perpendicular, all right? So this is where it's, this is a statement that we haven't worked with very much, but what we can say is, if this is the perpendicular, right? Essentially, we're talking altitudes, right? Then there's a conjecture. It's C-7 from lesson 3.3. That's called the shortest distance conjecture, okay? And what it says is the shortest distance between a point and a line is on the perpendicular, okay? If you remember, we talked about that. If I want to go from D to AB, any other point would be longer than the DE. So we're going to use this shortest distance conjecture, all right, and this is C-7, to make the statement that DE is the shortest distance to AB. And similarly, CF, there we go, is also the shortest distance, okay, to AB. All right, okay. And this here will justify those two statements. I would make these in one step, I would make these in one step, and then this would be one step, okay? So now I have to ask you is, what does that tell us? Well, that tells us that the measures of these two segments are going to be the same. If they're the shortest distance, then the measure of DE is the same as the measure of CF, okay? And what we would say is the definition, or the justification, the reason, we would say that that's a corollary to the shortest distance. I'm actually going to there we go, shortest distance conjecture. It follows from, okay, and that's a justifiable statement that we can make. And then finally, we can make that statement that DE is congruent to CF by the definition of congruence. The definition of congruence would say, that if the measures of two segments are the same, then they are congruent, okay? So This is one I would normally do in class, and it's not one that I would expect you to do on your own. At some point towards the end of the year, you'll be able to do a proof like this. But keep this in mind. This is kind of a cool way to prove that we actually didn't have to go through. It would have created far more steps to prove that this was a rectangle, okay? So that is proof number 1. So now the second proof, I said number 8 was number 1. It's the first one on the page. This one is proving that these two diagonals are the same, okay? So we're trying to prove that DF is congruent to CE, okay? And we have to think of a strategy. Again, if we thought about it, that if we could prove that this was a rectangle, that'd be one way to do it, but I'm going to try to be a little bit creative. And the first thing that I'm going to do is I'm going to say, hey, proof number 8 gave me this. So I could make that statement. And what I notice, hopefully you can notice rather quickly, is that I have two overlapping triangles, right? I've got one that's going like this, and then I've got the other one that's going like this. Well, if these are the same, okay, these are the same segment, if I could show that these are, I either could go with alternate interior angles. I've got all kinds of ways. If you notice, I could say this is congruent, right, this is congruent to this by alternate interior angles. That would not help me though, because that would be a side-side angle. And that would, that's what, again, if you look at, if I mark those, I have a side-side angle. That's a donkey. Okay, that's not going to work. And so then the question is, could I get this angle here? Actually, I can't, because these two aren't stated as parallel. The only way I could, and I could, is if I could say that two lines are perpendicular to the same line, then they must be parallel to each other. But again, we haven't proven that. So I'm just kind of brainstorming as I go through here. And I think I'm going to go back to, instead of, obviously that's not going to help me. If I can get this angle, I've got side angle side, right? And I can show that this is a right angle, okay, based on the fact that I know this is a right angle, that one will have to be a right angle. So that's the route I'm going to go, okay? So I did mark these two congruent, and that's because I'm going to show that as, I'm going to say, refer to number 1, DE is congruent to CF, and I'm going to tie in proof number 8, okay? I'm going to basically refer to that previous proof, and everything that's been stated in that previous proof is now already given. Does that make sense? I'm not going to have to rewrite everything, reprove that proof. So with this marked, everything that's been stated in here is going to be used now, okay? Now, it is given to us as well that angle DEA and angle CFB are right angles. Okay, and that is also, that's a given. Okay, so that would be a statement that I would use. Okay, now how could I make the statement that DEF and CFE, those inside angles, how could I state that? Hopefully you're thinking. Well, it turns out we also have had a statement, a congruency statement, that supplements of right angles are also right angles, okay? So if you think about it, right, if I have a right angle here, this is the supplement of that right angle. So this is a special case that the supplement of any right angle will also be a right angle. So we're going to use that little shortcut statement, okay? That's something we're going to rigorously prove at some point, but it's one of our conjecture supplements of right angles. Again, these are using some justifications we haven't used before, so that's why I like to go through these. It's also a reason to be having your conjecture list open in front of you, because you might find that something will make your proof much shorter and easier if you thought about it. But if you're always using the same reasons all the time, you're not necessarily going to be thinking about that. Well, hopefully you now know how to finish this, right? Because now I have this and that same segment. I've erased my two separated triangles, but I've got a side angle side, side angle side for those two triangles, okay? And so I'm actually going to let you finish this proof, because from this point onward, it's just like any other CPCTC proof that we've done. And then you are going to do the number 10 proof. And just a little heads up, I would separate the triangles out for number 10, sketch them as two separate triangles so you could track your corresponding parts. I was able to do that proof in 4 to 5 steps. It depends on whether you treat your givens as 2 steps or 1. Okay, it's a very short, easy proof after you've proven all of these things to be true. Okay, all right, see you soon.